Okay, I think we're ready to begin. Good morning, everyone. Welcome to the third installment of CATIA University. This is class number 3 out of a series of 7 webinars that we're putting together to help teach our customer base and others how to use CATIA. So class 3 is on relational design, templates, and automation. And with me today is Glenn Larson from Vias 3D and Chuck Giartana from Daxo Systems, and I'm your presenter today, Susan Crowden from Vias 3D. Next page. So first, the good stuff. Yes, we have graduation gifts. We're expecting that everybody on the call will graduate with flying colors. For each of these classes, we're giving away a $50 Visa gift card, but you must be present to win, so please hang around to the very end. Your name will be entered in a drawing, and you'll have a chance for a $50 gift card today and for the remainder of the class schedule. And for anyone who participates in all the class schedule, you can see it started in July and it goes into April. You'll be entered to win either a Space Mouse or an iPad. It'll be your choice. And there will be 5 lucky winners selected. So it does pay to learn. Next slide. Who are we at Vias 3D? Just so everybody knows who we are a Daxo Systems Platinum Partner. We're also a Daxo Systems Education Partner. We serve multiple industries, including oil and gas, petrochemical, aerospace, med device, etc. Our team consists of more than 100 employees with PhDs and high-level degrees in design, manufacturing, structural mechanics, etc. We provide engineering and PLM consultancy, training, software sales and support, automation, and customization. And we currently have a global presence with Nexus in USA, Canada, Mexico, India, and Turkey. Next slide. Who is Daxo Systems? Daxo Systems is the developer of the products that we'll be showing you today that we're showcasing. They are the developer of all the products that we'll be showcasing for this university session. They're the world's leading developer of CAD/CAM software. The product family consists of more than 120 interrelated products, serving 11 industries, such as transportation, aerospace, marine and offshore, etc. We'll be enabling implementation of design, analysis, manufacturing, and post-production support. They have over 22,000 people, over 12,000 partners worldwide, of which Vias is one of their partners. They have 290,000 enterprise customers with sales of $5.4 billion in USD. Our value at Vias 3D is provided through the application of digital technology, enabling manufacturing and engineering organizations to become better through connected collaboration, process discipline, and digital product experience. We're using digital transformation on the 3D Experience technology platform to provide social and collaborative apps that connect business users with social and collaborative apps. We have 3D modeling apps to do design, build, and simulate the virtual product world. We have simulation apps that simulate and optimize the virtual and the real. Information intelligence apps that analyze, predict, and develop insights from the data. All in 3D real time on the 3D Experience platform. So now I'm going to turn the presentation over to Glenn, and he's going to give you the 3 key takeaways that we're going to try to cover today. Glenn?
Well, thank you, Susan, and welcome everybody to our third installment of the CATIA University. As always, we've set this up with 3 key takeaways. So today, we're going to learn how CATIA supports connected engineering to use the relationship design techniques to quickly update your designs. We're also going to see how templates and rules, I left that out, will help automate and design engineering process. And then finally, we're going to discover automation using Process Composer, which has unlimited engineering automation capabilities. And I know some of this stuff sounds complicated, but let's remember that we can always take these subjects down to a basic level. I'm going to start with something very basic, which is a gear. And the relationship design in a gear. And I'm going to take one gear, and basically this is going to be 2 sketches, 2 solids, and a pattern. And we're going to use that to create a whole catalog of gears. So you could do this on a really simple level, and just to talk about what might be simple, let's say that you had a table design, and as you made that table design grow, you wanted the material to be thicker to support the weight. You could build that rule in there and automate. And so I just don't, although a lot of the demonstrations we show have some complexity to them, once you realize that these things can be used a la carte and in short format. So today we have kind of a simple one. We have a gear design. If anybody knows SAE gears, this is an involute gear. We don't draw involutes typically in CAD because it's a lot, your tolerance is a lot better drawing it this way, and this is the standard way to draw a gear. As you can see, it's got a pressure angle, so we're going to use, this is a 30-degree pressure angle, we're going to change it to a 20, and we're going to create a 20-degree catalog. You can see I've parameterized all the necessary dimensions to do a gear. And basically, we've got 2 sketches and a pattern. The one sketch is the tooth, the other sketch is the solid in the middle, and then the pattern is how many it goes around. And of course, we've parameterized all of the dimensions in here, which is not a lot. Okay, and you can see that the next thing that we do is we create a design table. And the design table works much like a spreadsheet. And in fact, when you open it up to edit it, you can import Excel, and you can also edit this in Excel. And it's kind of cool. If you had, let's suppose you were doing a whole series of nuts or bolts, or it could be machine tools, or it could be anything that you might have a catalog list of dimensions. You could import that in here. If you did your design table right, you can import that straight in and build it right off of the spec that you pull. Okay, there are 2 ways that you can do this. You can do this as a published feature, which we'll show you in a video down further, or you can do this like I'm doing this. And what we're doing here is we're creating a component family definition, and in doing so, it creates all the solid models. And I brought this one up because I wanted to show you that if the geometry doesn't work, or if you have some rules built in and some of those don't meet the rules, they're not going to build. They're going to fail, and you'll get a red light. So green is a model was built, red is failure. So let's see, it should be, okay, here we are. Here's the video on it. I've already got this drawn, and you can see again, I've got parameters with the relationships and then just a solid. So it's really kind of a simple model. So we're going to go through here, and we're going to start by opening a component family definition. And you can see I've got my table already built. And that's called a product table. Okay, and then we're going to go ahead and open up the component family definition app. This comes in almost all the mechanical engineering, so it's pretty easy to have. If you've got mechanical engineering, you should have this. And it creates a new object, so your original object stays as an original object. And it just brings this model inside that object. So this particular it's very easy to use. You basically check on this box here and execute, and it's going to execute everything you've got in your spreadsheet. And you can see it just doing it pretty quick. We had one failure. So you could go back and check that geometry to see why that failed. In this case, it's because I put random numbers in. So once that catalog is built, or that is built, you can put that into a catalog by simply clicking on the catalog button. And it would create that catalog that we had in the beginning. It's really simple to do. The other way to do this would be to, I'm just going to stop that right there. The other way to do this would be to take the, in fact, we'll go back up. If you were to take this and publish this, all of those parameters could be editable parameters in the published part, and you could bring it in as a published component as well, so you don't have to draw those models. It depends on whether you want the solid models or not. So it's just two ways of doing it. In the next video we're going to show here, this has things brought in that from published components, and there's rules built around them. So you're going to see that when you bring them in, you can edit the parameters are editable, or and run a check on the rules to make sure. In this example, we're using a injected component, molded injection component, and so there's a draft to it. So you want your published component to, you want it to be tangent to the surface, so it's got to meet the draft. And so it's going to run a check on it here. But you can see that it's just got a point that you can click on and insert that in there, that surface and the point. That's all it took to put it where it needed to go. And now it has all this knowledge where built into it. There's actually a bunch of rules up here that are going to, that we're going to check. It's going to run a check on it to see. So in this case, they're putting a battery holder in, I believe. Because if you have a battery and it's going to fit in many different components, you can publish that geometry and bring it on in. And you can see it's 90% complete by this little green here. And it's just going to ask for some more information. So you give it the information that it's asking for. And just OK. And so then it's going to put it in there. We're 100% complete. So if you're not using published components, it's something to really start to think about, because you can do a lot with it. You can save a lot of your repetitive work. I know in the NC machining world, they like to reuse different tool paths and things like that. In the design world, we can reuse a lot of standard components, whether it be a rib or whether it be a standoff or even a hole. You can even publish a hole. So the next portion of this that we're going to talk about are templates and automation. And this one's really cool. This one's going to be, what we're going to talk about is, the different types of catalogs that you can have. Here we have a catalog of machines. Here we have a catalog of features. And down here we have a catalog of rules. So, we think about rules as being complicated, but they can be really simple. Like I said, if you had you were building a table and the weight of the table grew to a certain size, you could use thicker, thicker pre-made parts. Anything like that as a rule could be made simple. Here we have some a little bit more complicated rules. What this automation is going to do is, this automation is built around somebody that designs cylinder heads. So what this automation is going to do is it's going to take components out of a catalog, and it's going to insert them where they belong, and it's going to design and draw a valve. And it's going to instantiate all of those inside the head. So now if you were, somebody that designed a lot of cylinder heads, this would make sense. But, think about this on simpler terms of what you can do with it. You can use this to automate very simple designs. And basically the inputs we're going to use are pretty simple. So this is a fully kinematic model when it's done. So when you can move the components. You can turn the camshafts in it, and it's going to move the valves up and down. And the way to do that is they have a template built. And the template already has the kinematics built into it. And as we pull in parts from the catalog, it's going to make those connections automatically. So you can see we have your kinematic connection up top to the camshaft. These are all going to be kinematic connections because in the 3D experience, anytime you make an engineering connection by default, it's kinematically capable. So, we're going to use our overall length of the valve to get the valve height to draw the valve. The valve diameter is going to come from these two locations. And the total package is going to determine which spring goes in there, which shim, and what tappet goes in. You can see that here, to do just the valve, we need the complete height of the valve, the diameters, and that's where it's going to get that information from. So that being said, let's watch the video, and I'm going to stop it in a couple places so I can explain it a little bit better. You can turn the sound off. I have a pretty good entry. So this is Templates Optimization Rules Designer. And that sounds complicated, but again, it's not. In this case, we made a good complicated demonstration, but this could be done at a simple level. So you can see that what we want to do is we want to draw the valves and we want to build the assemblies and put them in. So this is basically a spec sheet or requirements that need to be met to be able to do that. And it's kind of, it looks like a lot, but it's not. Not a lot of requirements to do what we're going to do. So now I want to stop here on the scripting because I wanted to talk about this for a minute because everybody sees this and gets scared of scripting right away. In the 3D experience, you can use Python scripts, you can use Visual Basic scripts. However, because it's a database and all the objects are already known, what happens is writing automation code becomes so much simpler. So if anybody's written Visual Basic code before, you have to give every object its name, where it is, where it's located, and what it does. Well, you don't have to do that in here. So it shortens code writing down. I can say it's probably only 25% of what you'd have to write. And there's really not as much to know because everything's intuitive. Everything's already named for you. So I just needed to stop and make that point that although this looks complex, we're doing something very complex here. You could do this on a very simple basis. Very simple rules could be put in here. So it runs a bunch of series of checks to say, well, what you need, what the inputs are needed to build and derive the output. And then we're going to look at the model itself. So this is the new head design that we're going to have. And you can see they pulled the knowledgeware in to be able to run this automation. And they have their prints and drawings and their different solids. So right away, you can see it's got some of the information it knows. Up here, we're 77% complete. And we're going to go through this and look at what information that we need, what's required. So in automation, when you need to choose information, you can choose it from, from the tree. You can choose it from the model component itself, or a pre-named, or pre-named object. So there's a lot of ways that you can choose, and it's great to go into the the background and just pick on the parts themselves, but you do have to be careful. I like to pick from the tree so I know what I'm picking, unless you're really, really good at visualizing and zooming in and making sure you choose your surfaces. So again, this is what the valve is going to look like. And we're pulling the diameter from the new head. We're pulling the diameter for the tappet, and the full length is being pulled from wherever we choose the different surfaces from. It's going to build this component with a shim, a spring, a retainer, a lock, and of course a tappet. So we're going to pull our information. You can see where from. And on the video, we're going to pick it from the tree. But again, you could just choose those cylindrical surfaces or those planes. They can be picked. The automation will know what the diameter of everything is when you choose it. So these are where all the catalogs are going to come from. These catalogs can be put, and you can see what, I'm going to stop again real quick. So the catalogs here that are built can be connected in the database in different collaborative spaces. So in other words, you could have it global or you could have it just per collaborative space. And so somebody doing cylinder heads might want their own collaborative space, and they may have this all set up so that their automation works. But if you'll notice here, and is that there's pictures here. So when you do those product family definitions, you can put in pictures, drawings, and text so that when your catalogs, you can have a view of what you're looking at. So it's kind of cool. It's something that we didn't do before that we can do now. And so those are all the catalogs that we're going to pull from the automation. They're not going to open up and show you like we're doing here. And you can see that when they built this, sorry about that. Let's get back over there. When they built this here, and I was going to stop here, we just have everything else turned off so you can see the seats and the planes and the surface that we're going to connect to. We're just looking at the action editor here to see what it's going to do. And we're going to run it. So now when we run it, you can see over here, each line item is something that we need to tell it. It's something we need to give it. So, the information can be added to the, to the library to go and get what it needs. So as you pick, and you can see we're going to pick from the tree, it's going to show up here, right down on the right-hand side. So now we have the lengths, the diameters, everything it needs to run the automation. Kind of easy. It kind of steps you right through it once it's built. So in the background, we're just showing you what it's going to do. It's going to find the right diameter and length. The intelligence is already built in. Because remember, it's really just length and diameter. Looks complicated, but in the end, it's not. Saving you a lot of time. These don't all open up like this when you're running the automation. We're just doing this to show you what it does look like, and we're going to create this valve. And then it's going to instantiate them in the head. That will show you that automation running. And I don't know if you can notice, but you can see it's putting them in position. Because it's already built with constraints and kinematics, they're going to go right to the position where they belong. Some valves are open, some valves are closed. So here we had success. If it didn't have enough information, it would have failed. So now you can do a cutaway and you can look at everything's built. You can see it put all the components in there, and they're all constrained properly. So you can see everything's connected properly. And now if you want to, you can jog it. This little jog window here rolled us around. So again, this is a complicated, or fairly complicated example, but you could do this on any small scale design that you wanted to, especially if you're doing repetition. I mean, you're saving your knowledge and you're using it over again. And I think that's what that's all about. So I think we've probably come close to the time when we would do the process composer. Be next. And so the process composer sounds complicated. Again, it's another simple tool that we have on the 3D experience. It's also available other ways, but the 3D experience is really where I see the most value. I have used Process Composer for all kinds of different things. So your imagination is the only limitation. If you wanted to automate your designs, you could use a series of what we just showed you along with Process Composer to automate some design. Here I'm showing you an example. There was a customer that had some requirements that they had different departments that would write information in Excel spreadsheets, and then they had a person that would tie all that together. Well, we saved them that pain by creating or showing them how to create a automation here that writes all of those spreadsheets into one and then uploads them to the platform. And so this can be done, just like we said, we had some spreadsheets that we can use to make design automation. You could do that way. You can see down here we have MATLAB, Excel, iSight, CST, Abacus, and Simula. Those are all apps that connect to this normally, but you can also use a command prompt. So you can pretty much run anything on your desktop. This is an example here of a design experiment that was built, a DOE, and what we wanted to see was the results from a bunch of different, this was light weighting. We took a connecting rod and we brought the connecting rod in. We gave it some parameters and information that we wanted to, and we used an outside software on our desktop to do the light weighting. And then we brought the information back into the 3D Experience platform, and we ran it in Abacus, and then brought the results up to the 3D Experience platform. And in a design experiment, you can actually, bring in a spreadsheet, you can use algorithms, you can use all types of different ways of creating it. Here, what we were doing, we were using lattice thickness as a variable, and to achieve a certain strength under a certain weight. And it's that simple. It was drag and drop, as I'll show you in the demonstration portion of it. So here, this is an example of doing some material calibration. And so here what we did was we had a target that we wanted to hit, and we had a component made out of a material that we ran a stress analysis in Abacus, and then brought the results back up to the 3D Experience platform. And here we had a target number that we wanted to hit. So, that's how we ran that. And all of this information is accessible. Anything that's in parameters, anything that's, a number in a spreadsheet, or anything that's comma delimited. You can also use Notepad. You can use anything you want, really, on your computer. This is an example of a simulation. Here what I did was I designed a plastic bottle, just a basic bottle, and I parameterized it and ran a simulation in Simula to determine what the thickness of that bottle should be to be able to withstand a certain amount of weight. And I'm going to show you the video. With that being said, so what they're showing you in here is today that designers want to be able to dynamically know whether what they're designing is valid. And so right from a design standpoint, you can connect to simulation using Process Composer. This is a motorcycle frame here we have, and it was just meshed so it could be brought in to be analyzed. But you can just drag and drop, and I'm going to stop this video right here real quick, and it's kind of hard to show you, but you can see that you can use Python script, you can use you can put parameters in, you can use 3D experience apps, just about any kind of application you want can be used here and put together. So it can be run in a series. I think I messed that up. Get back up to here. Okay. So again, to stop it there and see that when you, inside of Process Composer, this is one of the editors, you can see all the parameters. You can look at all the models and look through the depth of the parameters of anything that you put in there. You can look at the solids, all the Boolean operations, everything is accessible to you. Oh, I'm messing this video up. Wanted to stop it. Okay, here we go. We're looking at some, oh geez. Start over 3 times. I'm just going to let it run this time. Here we're looking at obviously the parameters, but we're going to look at some, and we're going to do some box automation here to look at how boxes would collapse and crush under different simulations. And so this was all done and used in Process Composer. I apologize about the speed of the video. And so basically anything that you want to do on a simulation can be done in Process Composer and added together. You can stack things on top of each other. It doesn't have to be simulation. Like I said, it can be running an Excel spreadsheet or doing a design. So it's only your imagination that would hold you back from what you could do in here. And so that being said, I want to thank you for watching that and open the floor up to some questions. I know we might have some questions on these subjects, so.
Thanks, Glenn. We do have a couple questions. And anybody that's out there, if you have a question, please just go ahead and put it in the question box and we'll try to get to all of the questions that we have today. So here's
Sorry, thank you so much for your presentation, Glenn. Yes, as Susan was saying, we have a couple of questions that we can address. So there's a really interesting from the audience. Let's say one of them says, does Process Composer have the ability to connect multiple applications? Is that what it is doing? What is Process Composer?
So, well, that's a good question. So Process Composer is an application on the 3D Experience platform. And yes, you can connect just about any kind of software you can have on your desktop, anything that can be accessed through a script or anything else. So for example, if you had Microsoft Office on your desktop and you could access it through a script, you could use a command prompt to access that. And it's meant to be able to connect not only processes but post processes. So you can, let's say you run one simulation, but then you want to take the results from that and post-process those results into another type of simulation, you could do it. Or, like I said, just Microsoft Excel. We connected in some of the ones to some outside design software that's not CATIA or not anything else. So if you had, other things like AutoCAD Inventor, let's say, or something that you want to access, you could. So you could actually change a design or something like that. Or if you had SolidWorks and you wanted to alter the design, you could do it from there. So that's how you could get some automation using SolidWorks. Would be one good way to do it. So I hope that answers that question.
It does, actually. Thank you so much. We have another one. They're asking, what is an optimization?
I'm sorry, what is a what? I'm sorry, come again.
An optimization?
Oh, an optimization. Okay. So there is a bit of a difference between an optimization and a study. So let me use an example. I'm going to use let's just use a hinge and a door for an example. So you might use a study to study what happens with using different dimensions, right? On where you put the hinge location, right? What happens to the door when you open and close it, depending on where you put the hinge pin. So those are, locationally wise. Whereas an optimization might be a target number that you're trying to hit. Let's say that same door that you wanted to maintain a gap between the inside of the door and the hinge of a certain amount, and you'd have a target, then you would call that an optimization. You're going to try to optimize something to be lightweight, to be heavy, to be different in size as an optimization. You have a target, I guess, is the point. That's kind of the difference between a study and an optimization, if that helps.
Yeah, it does. Thank you. We have another one that says, for the relational automation, the coding is it done in CATIA or using any other script language?
Yeah, actually, you can use just about any script language you want. You can use Visual Basic, you can use C++, you can use just about any language you have access to, because what you can do is you can run a command prompt, or you can run in just a script in a notepad. So anything that you can pretty much write is usable up here on a 3D Experience platform. And I think, if I don't know if I have, let me see if I've got a picture of it. I don't. But down here at the bottom, they have in utilities, there is a different scripts. A Python script can be run. Like I said, a Visual Basic script can be run, or just a regular, anything you can run in a command prompt. So hopefully that answers that.
Thank you, Glenn. We have another question from the attendees, which says, what is the difference between the abacus and simula in regards to how everything comes together? Is simula preferred due to native format?
Well, that's a really good question. So as we've gone through time, in the beginning, we used, there were things in Abacus that they didn't have in Simula on the platform available yet. So there were reasons to use Abacus. But every year there's less and less, Simula covers all of those bases. So I find Simula to be the preferred method, but you can run any Abacus command from Process Composer. So we did earlier on, we were doing springback simulations, and we needed Abacus to give us some of that information. And they've since changed that, and now I can get that out of Simula. So where I had a two-step process before, I now have a one-step process. But pretty much you can do most things in Simula. What they've done is, if you look at Abacus and you look at the different applications inside Abacus, those would be different apps in the 3D Experience platform. And the nice thing about the 3D Experience platform is that it walks you through it. There's an assistant that walks you through what you need. So it's a little bit easier for the layman to navigate, because it'll tell you you need this, you need the material, then you need this, then you need that. So I don't want to say less experience is required, but it's a little bit, auto meshing is easier. So those are the different things about simula and abacus. And, you know, abacus is still a great tool, but you can use both from there. So that's the nice thing.
Hey, thank you. We have a couple more. Do you always have to have a scripting to use Process Composer?
No. In fact, that's one of the beauties of Process Composer is the lack of scripting needed. So if you look back at some of the ones that we did, just to give you an example, there's only one line of script in this whole thing. It's just one line of script. And the only reason I wrote that line of script was to pull a picture out of Abacus to load it to the platform. And that was the only reason, because if I did that in simula, it would automatically be there. But since I was running Abacus, I needed to pull a picture. So that's what that little command prompt's for. But really almost hardly ever have to use scripting. Some of the post-processing and stuff that can be done on there, because it's pretty good at running Python scripts. And so if you had some post-processing that you want to do, but no, you don't need to. You don't need to know script. I'm not a huge scripting, you know, I don't know as much as some about scripting, and I can write in there pretty easily. I hope that answers that.
Yes, thanks. And we have, is there a way to access this capability if I am currently using SolidWorks?
Yeah, there is. There is. That's a good question. So let's suppose that you're using SolidWorks and you're using the 3D Experience platform. There are multiple ways that you can use this. First of all, in the 3D Experience platform, we can simulate directly on SolidWorks components. So we can use SolidWorks components for most things, you know, factory flow simulation, everything else. But let's suppose that for a minute that you wanted to change your design and you wanted to have something dynamic. You can, if you can get it to work from a command prompt in SolidWorks, you can make those changes from the platform. So the answer is yes. Yes, SolidWorks is very user-friendly with the 3D Experience platform. So if you got down to the individual things that you wanted to do, you could always reach out to us and we'd be happy to help you, guide you how to do it.
Great, thank you, Glenn. It seems like we don't have any more questions. So Susan, would you like to take over?
Sure. So thank you everyone for attending today. Next slide. And now for the lucky winner. I get to do the fun stuff. So the winner of the $50 gift card for today is, and pardon me if I don't say your name quite right, it's Hoi Vo. So Hoi, jump back one screen if you would, please. Please reach out to me at my email address, scrowden@viascorp.com, and we'll get you hooked up with a $50 gift card. Hoi Vo is the winner. Okay, next two more slides, please. Oh, so actually what that should say, go ahead, is it should announce the next webinar.
Yeah, there it is. I'm sorry.
Oh, what just happened?
I'm killing us here. Okay.
You're killing me. So CATIA University class number 4, I'm just going to speak over him while he's fixing this, is going to be on composites. So that's going to be a really awesome presentation. I think everybody will learn a great deal. I don't know how many people out there are using composites or thinking about composites or doing composites layup with Excel spreadsheets and your design software. That is a way to do it, but it's a slow and painful way to do it. So next week will be composites. Next week, I'm sorry, it's next month. And the date will be November 17th, same time, 9 o'clock Eastern, 12 o'clock that should say 9 o'clock Pacific, 12 o'clock Eastern. That slide is really super messed up. Sorry to say.
Yeah, I didn't. I don't think I had that slide created, so my apologies.
Okay.
But yeah, but the next webinar series will be done by our guest and an expert in composites. So be sure not to miss that one. It's going to be really good.
And again, the date's going to be November 17th.
Right.
I think that's the end of our presentation for today. I want to thank everybody for attending, and I hope you learned something new and wonderful about CATIA. Thank you so much.
Yeah, thank everybody for attending.
Thank you, everyone, and look for the replay in your email soon.
Thanks, Kenya. Thanks, Glenn.
Thank you, everyone.
Bye-bye.
Bye.